Welcome to another video in solving exercises in ADPRO. Let me clone the repository. Today we're going to do the monoid exercises, monoid and others, but I'll start with the monoid. Demo. We are in 110 monad. Let me open the build script. Okay, and the exercise text. Monad exercises. Okay, so the first exercise is asking for monoid instances for integer addition, multiplication, and for Boolean operators. We don't have immediate test for this exercise. Okay, so I'm supposed to edit the file exercises scalar. And I'll open a terminal, and I will also start the compiler, or actually start the test, but actually the first exercise doesn't have tests, or it does in exercise 4, and you need to get there to make them. Still running tests, even though they will be all failing. Might be useful because it compiles all the test files, etc. Let's give it a sec. Lots of things, everything. Here's a little hint. If you don't want to run all the tests, and we have several test suites this time around, you can actually focus on a particular kind. Since the first exercises are on monoid, I'll just pick the monoid spec, and it's a little less of error messages and a little easier to read. Then you can switch to the test suites for foldables, functors, and monads later. I'm searching for exercise 1. Okay, here we are. And the first exercise asks us to give monoid instances for integer addition, multiplication, and for Boolean operators. I'll just do the first one here. So in order to give an instance of monoid, I need to instantiate monoid. And the monoid has two operations. Since we are in integers, it will take two integer variables, and we were asked to do this with addition. So this is just going to be x plus 1. We're just providing the evidence that the operation is addition, and the identity element for addition is 0. That should do the trick. I jump a little bit into exercise 4. Exercise 4 asks us to find the monoid laws and use them for testing addition, etc. So the monoid laws are here in the laws object. We have the associative law that tests the monoid over A's. It requires that we are able to generate the elements of type A and to test equality on type A. For this particular example, we will not need to mess with equality, and for integers, the arbitrary instance is provided by default by the framework. The unit test or the identity test is also provided here. So, and both of these tests are combined here into a test interlocal called monoid that first checks associative and then checks unit. So if I go to exercise 4, I am asked to test in this exercise that the integer monoid is a monoid. How was that thing called? thing is called int addition, and it's placed here in the object monoid. So when I'm writing the test is placed in a spec file, so the object monoid is out of scope, but we import it as m, so I can refer to it through with the m name. So m.int addition .loss monoid. I'm just invoking the law, and let's see what will happen. Well, I cannot even check whether the test has passed, because the tests should not throw these question mark things. So if you need to implement all of them to be able to run them, or comment them out if you want to have the results earlier. Maybe that's what I'll do quickly, just to be sure that I'm showing you the right thing. Let's see whether this will fly. How many I have here? I haven't tried it before, so I'm quite excited what will happen. Oh, it still didn't work. Might be some other tests that are failing. I'll stop here, and I can just assure you that once you have solved the exercises 1, 2, 3 and exercise 4, and possibly comment out the other tests, although that should not be really a problem, the tests will be passing. Thank you.